Yeah. Next, we are going to discuss some another data structure which is called as queue. This queue is also called as a linear data structure. Here also we are going to discuss the fundamental topics. What do you mean by queue definition? What are the applications? What do you mean by ADT? Regarding to queue, we are going to discuss or we are going to cover all these three topics regarding to the queue. To the slide, here there is already I have said that we need to discuss about the queues. So first definition for queue. Queue can be defined as a set of elements or an area where set of elements are stored in a particular order. And what is the principle which is followed by queue? That is first in, first out. By seeing the name itself, we can understand that the element which is inserted into the queue as a first, that element only can be deleted as first. Then go for some real-time example for queue. You can observe, suppose a queue at the counter or a queue at the queue line. Here you can observe in this queue, we have taken 7 or 8 peoples. That 8 peoples are arranged in a queue. Then while leaving the queue, the first a person who is entered into the queue is removed or is leaved a queue as a first. So this is the scenario regarding to the queue. Then we'll go for next slide. What are the applications of queue? As we discussed, applications of queue can be divided into two categories. One is real-time applications and another one is computer-oriented applications. In the real-time applications, we are representing a queue in, there is a line, and the next one is waiting on hold for each tech support. Applications that are related to computer science, that is the threads. So all the Java programs are executed by thread or in OS. First the task can be given to a thread which is entered into the thread queue as a first. The process can be submitted to that thread first. Then only the process can be submitted to next thread. Job scheduling, round robin algorithm for CPU allocation. All these are related to queue applications. These are the computer oriented applications regarding to queue. Next we are going to discuss next slide, that is it follows first in, first out. Here you can observe queue. What is the fundamental difference in between stack and queue is, in the stack the insertion, deletion or push or pop operation must be performed at only one end, that is top of the stack. But here in the queue we need to take two end points. One is rear end point, another one is front end point. Front end point always is used for performing deletion operation. Rear point is used for performing insertion operation. So we have two pointers, one is front pointer and rear pointer. So while performing insertion operation, we need to increase the rear value. While performing deletion operation, we need to increase the front value. So this is the scenario. Here you can see, first we have inserted A. While inserting A, we need to increase the rear value. Then we need to insert B. While after inserting B, we need to increase the rear value. But front must be always pointing to only first position while performing insertion operation. But while performing deletion operation, rear must be same. Always the front value must be decreased. This is the scenario regarding to queue. Then we need to go for queue ADT. Here also, to perform push operation, and that is insertion operation and deletion operation, we need to follow some conditions. That is queue will be full or queue will be full. When we can say the queue will be full, if the number of elements is equal to maximum size, then we can say the queue is full. Other time it return true, else it return false. Next we can go for, if queue is to create the queue, first we need to check that queue is empty or not, or queue is full. When we can say the queue is full, number of elements in a queue is equal to maximum number of elements into the queue. Then to perform next here, we need to check is full. If the queue is full, this function can return true, then queue is full. Otherwise then we need to insert, otherwise means queue is empty, then we need to insert an element at the rear end of the queue and return a queue. This is the scenario to perform insertion operation. Then we need to go for another operation, that is pop operation. To perform the pop operation, we need to check that queue is equal to maximum size. Then it return true, that is nothing but queue is, see, if the is empty function, we need to check that. If the is empty function is true, then it return queue is true. At the time, pop operation should not be performed. We should not delete an element from the queue. Else means the queue having some elements, then we need to delete an element which is pointed by front then we need to delete that element, then we need to increase the front value. This is the scenario how insertion and deletion operation must be performed on Q. Then we need to go for next slide. As we had discussed, here arrays are also queues are also implemented by using arrays. So that is we need to specify the array size first. As with array based stack implementation, the array is of fixed size, queue of maximum number of n elements, slightly more complicated, need to maintain. Why? Because we have 2 pointers we need to maintain, front end and rear end. Here you can see, here we have deleted 0th element, first element, second element, third element, then front pointing to 4th element. We want to delete 4th element if you want. If you want to perform insertion operation, here we need to insert an element at a point which is pointed by r. N minus 1 represent number of elements into the array. Then go to the next one. Here r represents a location where we need to insert the element, and front represents an element which is we want to delete from the queue. Then we need to go for next slide, that is algorithm for performing queue insertion and queue deletion. See, here also we have taken one structure with int key, and then we have taken some array, that is queue array. If rear equal to -1 and queue front equal to -1, we can say that the queue is empty. If queue is empty, front and rear is equal. If rear is equal to maximum size -1, we can say that the queue is full. These are the two conditions to say that when the queue is empty, when the queue is full. Then we need to go for next slide. This is the algorithm to perform insertion operation. So we need to check that rear is equal to maximum size -1, then we can say that queue is full. Otherwise, that is return means come out of from that algorithm. Otherwise, we need to insert an element into the, first we need to increase the rear value, then we need to insert an element into the rear position. This is the scenario we need to repeat until number of elements into the queue is equal to, so that is until the rear is equal to number of elements. Then the queue is full, then come out of from this algorithm. This is the scenario or algorithm to implement insertion operation on the queue. Then we need to go for a DQ. Here we need to perform deletion operation. To perform the deletion operation, we need to check that queue is empty or not. To check queue is empty, already we have mentioned front is equal to rear. If front is equal to rear, we can say that queue is empty. Otherwise, queue is having some elements. Before we are deleting an element from the queue, here also first we need to increase the front value. After increasing the front value, the element which is pointed by the front, that element must be deleted from the queue. This is the scenario. Then we need to go for another slide. Here we need to discuss about that how the insertion should be performed in circular queue. Here, so regarding to the circular queue, always the last position of the queue again can pointing to, from the last position again we can shift it to first position. Because of that reason, here rear value is equal to rear plus 1 modulus maximum queue size. If this by using this formula, we can get rear value. If front is equal to rear, already we know that is error. At the time error. Otherwise, we need to insert an element into the rear position. This is the scenario or algorithm for inserting an element into the circular queue. Then we need to go for, we are going to delete an element from the circular queue. To delete an element from the circular queue, we need to check that queue is empty. If the queue is empty, we can't perform deletion operation. If the queue is not empty, then only we can perform the deletion operation. To perform the deletion operation, we need to take front is equal to front plus 1 modulus maximum queue size. If then, after getting the front value, we need to delete an element which is pointed by front. This is the algorithm for performing deletion operation on the circular queue. Okay, thank you.